So now starts another new old computer show, or a new old computer stream. Thanks for everybody who is watching, listening, commenting. Recently, I made 2 videos about the Dallas clock chip, and I got a huge response. These were my first edited videos, and it was a great learning experience. And I'm honing my skills, my craft. I'm learning the tools. So thanks you all for, who commented and gave feedback. That was incredibly encouraging and fun. So I'm not going to be talking more about the Dallas clock chip today. Still have the Canon PC sitting on the floor over there. I've ordered a couple of parts to deck it out a bit and fix some other issues. I'll get back to that eventually. But today I wanted to try and wrap up some loose threads. So the SC30 is back on my desk, so that's gonna get a little bit of attention. Oh, hi Zombie Geek, welcome. So yeah, I'll see. Hopefully, I'll be able to put the SC30 back together for now. And I'm also gonna address the BlueSCSI V1 hack that I did last week, and also try and do some more troubleshooting on the BlueSCSI V2 that's a little bit marginal. So I think to start out, so I had this long stream last week trying to hack BlueSCSI V1 so that it can fit into 32 kilobytes of flash memory on the lower spec STM32 microcontrollers. And at the end of that stream, spoiler warning, I was able to actually get it down to less than 32K, so that was a pretty cool cool process. However, after sleeping on it and looking at the code again and actually trying it, I realized that it doesn't actually work, unfortunately. In the process of actually towards the latter 20 minutes or so, and I was really tired, I did comment out the piece where it actually reads the image. Let me just show that briefly. I'm gonna bring up let's see here. Maybe I'll bring up Visual Studio and Git. So let's see here. Here's my computer. So yeah, we have BlueSCSI up here, and I'm gonna bring up. I think I can do it from here. If we go into BlueSCSI, go back to my work branch, and I'll just show you what I did wrong. So this commit hash here, E376, that's where we actually reached 32K. But then I went back and did some cleanup to get the code to actually work again. So let's have a look at what that is. 1150. So ignore the first piece there. Yeah, I did comment out a few pieces about the directory structure. We don't need to walk through directory structure. And just commented out this contiguous check. But the meat is down here. So the mistake I did towards the end, as we were getting rid of the image set code, I commented out this call to find drive images, and that was the last call. Like that's where the BlueSCSI code goes in and tries to find the drive images and then actually load the drive images. So what that does, it just doesn't call this entire function here, right? where it sets image ready, and it does the it creates the SCSI device object, the file object, and it sets some parameters, and then it does the HDD image open. So that's where HDD image open is called, with the device and the file object, and then it sets the it does some bitwise operation on the SCSI ID mask, and that SCSI ID mask, that's what the BlueSCSI code checks later to see if images were actually loaded from the SD card. And needless to say, if you don't do that, you don't get any drive image data. And yeah, so that's what brought this. So what the compiler then did, of course, when you compile that code, was to just optimize away and the entire SD card file system library and code and stuff. That's why we saw that big 8K drop at the end. So yeah, unfortunately, we are kind of in a little bit of a problem there. Actually, so let me quickly load the let me build the code and show you how big it is now. So let's run that. Let me bring up, I think, oops. Whoop, 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 whoop. So this is a thing, right? So these are the steps that we took, and we reached 32,000 bytes. But now it's back up to 40,196 bytes. After 7th pass, which is restore file loading, file handling. So I think on the positive side, that tells us that the part of the code that does all the file handling is pretty heavy. Basically, like the SDFAT library and the file object are the what were they called? File object. HTTP image open. Fine drive. Yeah. So this the FS file class, right? The object you create. It's the Arduino file object. This is heavy stuff. So I was chatting to Eric afterwards, and the idea, the lead that we have right now is, well, why don't we just get rid of the entire SD card FAT file system handling altogether and just read raw bytes directly from the SD card, the storage media? That should have a very similar effect to just getting rid of that that chunk. So of course we may have to add some code to do that. So and it will be tight, but it's probably still very much doable. But I think that's gonna be not project for tonight. I will try that another day. So yeah, I better read up a little bit on how to operate raw bytes on with C on a STM microcontroller. So anyways, I think that's it for the BlueSCSI wrap. I just wanted to kind of leave a record of what happened after that stream. If somebody follows along, I left it off at the cliffhanger at the end of the stream there a week ago. So, well, then thread number 2 is to have a second look at the BlueSCSI the V2. So BlueSCSI trouble all day. So just as a recap, this BlueSCSI does work. It functions. It just has a massive voltage drop on the 5-volt rail. Hi Brendan, thanks for joining. So something is not right. It's either something has too low resistance to ground somewhere, or there is some kind of malfunctioning component that's adding a bunch of resistance. There could be resistors or diodes or ICs that are misbehaving. So I'm gonna do just one last round of troubleshooting on this myself until I send this back to Androda for him to look at it with expert eyes. But I did have a chat. I did have a chat with Androda a couple of days ago, and we did go through a couple of steps, checking the obvious stuff. So I'm gonna just walk through those again just to show what we've done so far. But I think first things first, we should check that this is still a problem. I don't expect it to have changed its behavior, but you never know. So I think I want to get the old SE30 hooked up again here real quickly. It's a good thing I still have my test harness up. Easy to work with. Let's hook up the extension. Maybe I can angle it a little bit like so, just to show what I'm doing. Then we have our SCSI cable, of course, like so. Just need, oh, there it is, okay. Then of course I want power cord to get some power. Of course, it's good to remind you all that it's generally not advisable to power a machine like this without its housing. And there's a lot of high voltages flying around here, at least, what is it? At least 10k volts through the anode cap here, and a lot of high voltages on the analog board and then the power supply. So please proceed with caution if you are doing this at home. Yeah, so I think that should be about right. Bust out my multimeter. Just measure the voltages. You can see just to the edge of the screen there. So the easy way to measure the voltage, that the 5-volt rail that's on the BlueSCSI board itself, is to check any ground points against the power on header. So the power on is the header that allows you to enable and disable the 5-volt rail on this device. So yeah, that's where we have the 5 volts, and then you take any ground really, and it's handy to know that when with these 50-pin SCSI headers, these 50, I don't know how to express it, but yeah. Oh, actually, so we have the pin 1. It's hard to see here, but pin 1 is here, like it has a different shape So the entire first row of pins are ground on 50 pin SCSI, so you can measure against that. So yeah, if we put the negative probe in ground here, and then turn on the computer, then we check against power on. Yeah, so you see that 3.8 volts on the 5 volt rail, and that's not very good. There is also term power. I think term power is somewhere. Let's see if I can find it quickly. Ah, there it is. So it's, let me show you what I'm measuring on the bottom of the BlueSCSI there. If I can find it again. It's one of these. So weird. There we go. So yeah, 4 volts, 4.1 volts. That's the term power, and then that's that voltage is dropped a little bit to 3.8. So yeah, that's way too low. It should be closer to 4.5-ish, I think. It's also good to check. So the voltage regulator that sits on this board, I think it's C2 here. Yeah, sorry, I'm talking about something's not on screen. Let me switch over to the bench. It's a bit of a weird angle, but I'll fix it later. I was messing around with my my camera before. I was going to check the 3.3 volt rail on the Pico. 3.8 volts goes in. 3.6 volts. So okay, I can see it here. Let's turn it around. Yeah, so the 3.6 volts seems a little bit high for 3.3 volt rail. Oh, I think that's the correct one, 3.28. Yeah, so it's getting a good 3.3 volts. But yeah, it's borderline not enough. So we have confirmed that same problem still occurs. Let's turn this off. Let me adjust this camera a bit. I think I need to bring it down. Please bear with me when I adjust this. Okay, you know what? My problem is that I put the arm the wrong way around. I'm gonna switch over to this one momentarily. think that should give me a bit better angle, like so, perhaps. A little bit of a glare there. That's good. I think this is pretty good. Actually, I meant to when I first started down this troubleshooting path, I meant to demonstrate that if you hook up 5 volts directly from the power supply, which you can do with a Molex to Berg adapter like this, the problem does go away. So I'll just demonstrate that right now. So this is what I'm doing here. I'm hooking up, this is the Molex that goes from the analog board normally to the hard drive. So if we create this direct connection to the BlueSCSI, we do get perfectly good 5 volts into the device. Let's see here. So now this cable is a bit short, so it's just flailing around over here. Okay, maybe like so. I want something to short out. So I'm just gonna measure again from the power on header to ground to see like so. So turn it on now. Yeah, so with Berg, 5 volts served directly from Berg, the Berg header on the BlueSCSI, we get 4.7 volts, which is great. That's exactly what we want. So it works, right? But I still feel a little bit iffy about putting a marginal device into my computer and forgetting about it. I mean, I could use it in a pinch, but I much prefer it to work within spec. You know, if a lot of voltage is being drained through some component. I mean, I tried the heat test to see if heat was generated anywhere, and no components get really hot except the LEDs, perhaps. So I don't know if the LEDs are marginal. Maybe you can remove the LEDs and see if that does a difference. But yeah, I definitely prefer to find the problem with this before I commit it to a machine. So let's see here. Let's switch back to the desk, like so. Okay. So let's try. So I'll put my multimeter to resistance, and yeah, step 1 in this process is to see if there are obvious shorts, or at least areas where the resistance is lower than expected. And as per Androda, it's good to measure against the backfeed header. So he says, maybe I can bring up, actually let's, I think I have a page with the schematics. Let's download this. Here we go, okay. computer. So this is the top of the BlueSCSI board. Of course, there's a bottom as well, but that's just a couple of traces, no components. So this is pretty much all there is to the BlueSCSI V2. And you can see the power on there to the left, the right hand side, the bottom right. So that's where the 5-volt rail passes through. It goes through a diode. So the first drop comes through diode D2 there, the diode. Of course, that's through that trace goes through the 5-volt on the Berg. And yeah. And the other trace to power on goes through the U3 voltage regulator, which gives us the 3.3 volts. So anyways, we wanted to check the so check the term power line to ground. Term power. So that is right here. So let's see here. I think that's what we have. So from the right side of diode 1 down to backfeed, we have 0.76 kilo ohms, so that's plenty of resistance. Oh, sorry, I was using the probes the wrong way around. Oh no, I didn't. Okay. So from the left side of D1 to ground, yeah, that's at 0.75. Anyways, so yeah, so we don't have a short from the 5-volt raise to ground. So we want to see how the diodes measure outside of the circuit. So yeah, the diodes can't be measured in circuit because they get affected by other components. So we need to see if it makes a difference. Or actually, we'll see if they measure correctly out of the circuit. So what we want to do is to take these two out. Maybe I'll show it under the microscope. There's D1. We want to take that out. And then we have D2. And take that out too. And then of course we have the LEDs, which are also diodes. So let's see if we can just do a little bit of hot air and see if they come out. They should come out easily. Now, I'm not sure, are these diodes are always polarized, right? I'm not sure I see any polarity markings on oh yeah, there's a little bit of a oh yeah, there's a line there on the left side of the diode. Oh, and then we have also the silk screen is like a shroud on the left side. So that's the polarity there. All right, so let's just do some hot air action and see if we can get these out and then measure them. This should be straightforward. $350. Actually, I should take out the jumper. We don't want to melt the jumper. Let's start with D1. It's over here. D1 is out. Right. So let's set our multimeter to diode mode, like so, and see what kind of a measurement that we get. So it's always a bit fiddly to test SMD components. So that's test 0. Overload. And we should see a voltage drop, so that the overload is weird. Are we not getting good contact? Yeah, that's just overload. What if we test continuity? So there's no dead short, at least. So I don't think that's correct. So either my multimeter can't measure this properly, or there's something wrong with this diode. So let's put it aside and take out the other one. Shall we test what happens when this BlueSCSI runs without D1. Let's see what the schematic says. Yeah, so D1 takes the 5-volt rail and goes to the back feed, goes to the capacitor, and then ground. I don't know if this is advisable, but let's just have a quick look to see what happens, just for fun. No SD card. Let's measure on the power in header. Yep, nothing. Oh, wrong way around, but yeah, doesn't matter. Yep, so no power. Anyways, let's take out the other diode. Out it comes. Should have checked that the polarity was correct. Yes, polarity was correct. Okay. Oh, was I using the wrong? Yeah, I think I was using capacitance. Yeah, sorry. I guess Sunday night I don't have. I need to wake up. So we should be we tested that the diode doesn't have capacitance, so that's good to know. Now let's see what diode mode gives us. Okay. So yeah, we have a 0.18 voltage drop. It seems a bit low, but I don't know about these particular. Oh no, this is what happens when you apply too much force on these SMD components. They pop away and ends up on the floor. Luckily it was easy to find. Uh, 1.85. Sorry, 0.185. So they measure the same. So yeah, I think these diodes are fine. Just for fun, let's install them the other way around. So this one needs to go in D1 and this goes in D2. So yeah, let's turn on the soldering station. Check the polarity, the little band. Yes, the band is in the right orientation for the board. Let's remove the original solder to make it easier to get it flush. The wick took a little bit of the solder mask with it. That's less than ideal. Need to be more careful. So my usual trick when just doing one-off soldering of SMD components is to tin one pad, take the tweezers, place the components, heat the solder while holding onto the components, wait until the solder solidifies, and then put some pressure on top. Oh, it doesn't really stick on there. Okay, my method is failing me right now. Maybe I need to use flux. Okay. That worked out, finally. Double check polarity. Yes. And then heat the other side and add some solder. And the components should be on there, all right. On to the next one. Remove the existing solder. Tin one pad. Double check polarity. Yes, it should go the other way. Put it down next to the solder blob. Heat the blob. Slide the component into the molten blob. Release. Apply force on top. Oh, gosh. Yeah. I just like to get the components really nice and flush, so that's why I do the intermediate step. But it seems like this diode is pretty tall, so when I apply the pressure on top of the cap, it very easily falls over. Oh, damn it. Did I put it on the wrong way? Yes, it's on the wrong way, so it's good to put the polarized components on the right way instead of the wrong way. Let's try again. Like so. Okay. Yeah, this method is not great for this particular diode component. I think I should change my angled tweezers. That's pretty good. Do the other side. So that was messy, but I think they're on there now pretty well. Clean up. Triple check the polarity. I think that's okay. Now let's test if I broke the device or if it's still working, and whether it's any different from before. I don't doubt it, because we just took two components out, swapped them over, and nothing else. Let's go back to voltage. Oh, we're actually not powering the device right now. So we're getting 4.64 without the power on header. Let's turn this on. So now we're actually powering the device, and then we're getting 3.76. So yeah, the problem is exactly the same. So something here is drawing more power than it should. I don't think there are any other diodes on here. Just for fun, let's pull the oh, hi Xenophite, welcome. Let's just remove the LEDs and see if that makes a difference, because they are the only components that get hot. Obviously, I mean, they are LEDs, they get warm by design. But let's see what happens when you remove the diodes. I think I'm pretty sure there are little band markers. Let's have a look in the microscope. There are the LEDs, D4 and D3, power and activity. So you can see there's like a little green band speck thing going on towards the, again, the shrouded area on the silk screen there. So that's clearly the polarity marking. So let's yeah, let's for fun, let's pull these diodes out, see what happens. Let's take out the these are very small components. I don't know if they will survive this process. I assume so, but not melting. It's because there's so little solder on them. Oh, there you go. Came out. And it's stuck on my tweezers. Poor thing. Let's check in the microscope that it's still intact. This is the underside, I believe. This is gonna be fun to solder back on there. It's the top, so yeah. You can see the polarity marking is still intact there. The green speck. Let's keep it there. This board is quite hot now. I think we should let it cool down before powering it up. Okay, I think it's cool enough. The activity LED still turns on, so that's the thing. Oops. See if we still measure the same. Yeah. 3.8 something volts on the 5-volt rail. That did not make a difference. Let's pull out the other diode. Oh, I should. Sorry. I should disconnect. Door. Okay, activity diode came out. the underside. Yeah. Sticky tweezers. Sticky, sticky, sticky. So I guess it doesn't matter a huge amount, but you have to remember that the one on the bottom here. Oops, now it's on the top. But the one, let's move it down again. Come on. Oh my gosh, stick. The one on the bottom is the activity LED, and the one on the top is the power LED. They are different colors. Okay, I think this is cool enough to power on again. Of course, we still have the LED on the Pico itself, but I'm kind of inclined to trust maybe it is something weird with the Pico itself. That would be obnoxious. Yeah, same 3.8 volts. Oh, yeah, if you put the probes on the right way, of course. Same 3.8 volts. So yeah, not surprising, but the LEDs have nothing to do with the problem. I just wanted to test all the diodes. Okay. Sorry, my dog is bored. She's sitting over here. Easy. Looking, she got her evening walk, so I'm not sure why. What do you want, dog? Huh? So let's see if we can solder these diodes back. This will be fun because they will absolutely stick on the soldering iron. But let's try we just tin these pads. Grab them with the right polarity. Oh yes. And then so yeah, wish me luck. Just hold on. Okay, sorry, I need to switch back to the bench. So I'm gonna hold onto the LED with my tweezers, heat the pad, slide it in, wait until it cools. Yeah. It's a little bit off. It's on there, it's just a little bit off, too aligned. It's not very well aligned. I get anal about these. I want nice alignment for my components. So let's just try to shift it a little bit over. Okay, I think that's in a good spot now. I should use a smaller tip really, but it works. Okay, let's grab the other one. So here the polarity spec is on that side. You just spin it around. Oops. Okay, it's on there pretty nicely. And then solder the other side. Just clean it up. So yeah, not the best alignment, but they're on there. So let's see if the LEDs light up when we turn on the BlueSCSI. Yep, it's hard to see perhaps. The power LED turn on, the white one there. Let's see if when we turn on the put the SD card back in, do we get activity as well? So anyways, we're kind of at still at step 0. So yeah, maybe it is the pico that's marginal. And I don't have any others to test with, unfortunately. It's funky. I got a flashing question mark on the screen there, so... Huh. Did I ruin something? I don't see any obvious damage caused, so I'm not sure why why it's not working. Let's check the data on the SD card. But anyways, this is kind of it's a moot point, because I'm gonna just spend a couple of minutes to let's see here. To actually get the SC30 together. Yeah, just FYI, I was looking at the BlueSCSI log to see if there's anything. ROM, okay, not ROM. It's doing image ready, initializing. Yeah, I'm not sure what the problem is. Oops. What happens if we turn off termination, just as an experiment? Same 3.8, so that didn't make a difference. Yeah, sorry, I'm chatting with Androda. He says that he's not suspicious of the Pico because the Pico SDN termination will hang off the power input. He's more suspicious of the terminator. Yes, it happens when both termination is enabled and disabled. Now, if you pull the 2.85 volts regulator and the issue is still present, that removes transceivers at the source. And that's yeah. Weird that we can't boot even anymore. Let's try one more time. Let's check the voltage. Pico 3.3. That's correct. Okay. Now the Mac boots again. So I didn't. It's hard to see, but you take my word for it. There's a happy Mac on the screen again. I can see it there. I can see the reflection in the TV that I have in front of me here. Maybe it was just, oh yeah, there we go, Mac OS. So maybe it was just overheating or something from all the hot air. Okay, so Androda says the IC next to C2 by the termination selection jumper. Oops. Computer, yes. C2. Yeah, so one last thing to test then. So let's turn off the computer. See what happens if you remove the regulator. So let's pull that pin out. Let's bring the hot air out. And then let's remove the regulator and see what happens. sort of removing no progress. There we go. We need to let it cool. So yeah, without that, I don't think the will the Pico get power now? Still pretty hot. So yeah, this just as a recap, but to repeat, we are trying to see if removing this makes a difference with the 5-volt rail, and that will tell us if the transceivers are drawing all that heat, or not heat, drawing all that voltage. Rather. Okay, I think it's acceptably cool now. So let's run the BlueSCSI again. Power it through the termination. Okay, so the Pico turns on. Okay, cool. So it's being powered from somewhere else. Let's see if we see something different. Measuring from ground to power. Oops. 3.84. So slightly higher, because now it's not driving the transceivers. But yeah, definitely still not happy camper. Pico is getting 3.28, which is perfect. But yeah, the 5-volt rail is still very unhappy, 3.84 volts. And without the transceivers, there's definitely nothing happening on the bus there. So yeah, for those of you who don't know, Androda is the co-creator of BlueSCSI and the designer of the BlueSCSI V2 board, and I'm chatting with him on a different channel here, helping with pointing me towards stuff to test, because frankly I'm not an expert on the BlueSCSI design. So I think we should change gear. I really just want to put the whole computer together. I'm gonna pull the BlueSCSI out, and let's switch gears and see if we can just assemble this computer so we can sort of get a little bit of closure on this thing. So put these away here. So I've gone ahead and just pulled out the BlueSCSI V1 1.1. This used to sit in my Mac 2SI. So I think just in order to have a fully functioning, well, put together computer here, let's use that one for now. Let's see here where there it is. Looking for my micro SD card. So let's put this computer together. I'm gonna pull up the drive bay here, and the BlueSCSI. This sits in this 3D printed bracket made by my friend PotatoFi, and it's an original PotatoFi print. Let's see if we can get the scene out here, like so. I don't know what's a good angle. So let's try that. Let's test that it works first of all before putting everything together. In fact, I should not have removed this. Let's put these things back together. Before assembling everything, I want to make sure that it actually works. Yeah, it's a great bracket. PotatoFi sells these on his Etsy store. So let's hook this up and see if we can get a working system. So this is the LED header. There is a little activity lights header on this board here, and the positive is facing that direction, so I'm gonna connect it with what I hope is the correct polarity. And luckily this stock header fits on this. This was 0.1 inch. So as I know, I haven't tested the. Thanks again for printing some brackets for me. That's an upcoming project. I will use them shortly. And now let's prep the micro SD card. So I'm gonna put my little adapter into the PC here, and just to kind of short circuit what we're doing. So I'm just gonna leave this one on here. I have a collection of bootstrap images here, just to make sort of that step, so you don't have, instead of installing a system from scratch all the time. I like to do that too, but just for today's purposes, I'm gonna use this 2 GB file here, which is a pre-hacked version of macOS 8.1 with a fallback to 7.5.3. And it's pre-hacked for the 32-bit clean ROM on the SE30. So that should, if everything works, that should boot right up without any further modification. And if you want to use the same, you can. There is this. If you go to the BlueSCSI wiki, see if I can find it. There is this. I think on the usage, pre-made images. Yeah, so there's this collection of blanks and pre-made images on this mega.nz shared folder. So if you go into pre-installed, you have this one, Mac OS 8.1 SE30 ROM upgraded. So that's where you can get this image yourself. It's very handy, so you don't have to do all the res edit hacks yourself. Almost done copying. And of course, let's see here. Once we've tested that it boots, actually let's do that now. So I have here. So here is the original 64 megabyte that I had in this machine earlier. I also ordered another 64 megabytes, 30-pin SIMs from UWC. So here we go, brand new 32-bit, 32-pin. Actually, these are just 2 SIMs. We need to fish out the others. 2 more. And this image has been copied over. Let's eject this micro SD card. Just put the micro SD card in the BlueSCSI, and so actually there's been some damage to the micro SD card holder there. That may or may not work. So this the cover just popped off early today, so I may have to actually do repair on this if this doesn't get good enough connection. It's not really holding on the card there really well. So yeah, this may not actually work. But let's see if we can read it. So let's turn on the computer and see what happens. So it's not complaining about a missing SD card. Yeah, so it's working. But I think I may have to swap out the micro SD card holder on this one. So yeah, literally, you know, as I was preparing for this video, I was pulling stuff in and out of this BlueSCSI, and off came the top of the micro SD card holder. A card, it's not a holder, it's SD card slot. If you make a giant RAM disk with all that, it will be way faster than any flash-based SCSI storage solution. That's a good point. Yeah, we can put all our software on the RAM disk. So anyway, it's booting into Mac OS 8.1 now. I'll show you that. I'll probably turn it off right now and hope that it doesn't corrupt the image, because it's gonna stop. It won't be able to actually load 8.1 with all that crap, because it's only got 8 megs of RAM in here. So let's install all of the RAM. So this is where you hope you won't break the SIM slots. They're just really fragile. Yeah, yes, you are correct. I think the original spec for this machine was a 40 megabyte drive. Alright, so we have 8 megs out of the machine. Let's install 64. Sorry, yeah, first the first 64 and then the second 64. And hi, Burly Bear. I'm sorry, I don't speak German. Grab my scissors. Oh, sorry, I didn't show off the cutting of the bags, but at least you can see me sliding them out. So there we have brand new, factory fresh, 16 megabytes, 30-pin RAM sims. Let's put them in there. Sure they go in the right way. Okay, there you have it. Perhaps I should demonstrate like so. If you've got RAM in your pocket, you always get a snack. It's a nice lineup of RAM there. So let me turn the screen around. And see if we can get a shot of this without shorting anything out. So the logic board is kind of hanging precariously on the side there. It's not great, but let's turn this on and see if we get lots of RAM. And I don't have this speaker hooked up, so yeah, we don't get any chime. Let's turn off the studio light. Alright, happy Mac. And this webcam is just not doing a good job shooting a Make sure your pocket is grounded by RAM, so the RAM doesn't get damaged by static. Not sure what you mean by pocket, but it's on the sitting there on the desk cover. Yeah, that's true. The RAM startup test is disabled. That's part of this hacked ROM on the Mac sim there. So yeah, 16 megahertz CPU is definitely taking its time loading macOS 8.1. But unfortunately, I'm not seeing LED activity, so we're kind of back to square one with the LED stuff. Is it reverse polarity? So yeah, I guess we have to continue the mission of getting the activity light. Yeah, the LED is dead. It's not dead, but it's not lighting up with whatever power comes through. Actually, let's check the voltage. Oh, that's never mind. Yeah, no, I'm not seeing any voltage come through on either the power or activity LED the headers there, so maybe I haven't hooked it up correctly. Yeah, so I mentioned earlier that this is a pre-patched version of macOS 8.1 that I got off the BlueSCSI wiki. So it's funny just how huge a difference going from System 6, right, to something like this. I don't think... No, there we go. It's not frozen. It's just taking a very long time to boot. So yeah, this is why you want a 68040 accelerator in your C30, so you can actually use modern applications. Oh, well, I guess it will probably run fairly well once it's booted up, but yeah, there's a lot of code to execute, a lot of stuff to read into memory when booting the bloated macOS 8.1. And of course, this is a universal system installation. So it has a whole bunch of crap that's probably useless for this computer. Oh, well, I guess it is customized for the C30, or it is specifically for the C30, but you don't need the speech extension, I think. Can remove that one. I probably need to hook up keyboard and mouse. They're sitting over here. I have to be careful not to bump into something. Careful not to short out the ADB port. There we go. I can move. I think you can barely see that. I can move the mouse cursor now. Yeah, I think ADB's You're not supposed to hot plug ADBs, but ADB devices, but you can. It's mostly okay. Sorber79 asks, I haven't watched your previous videos. Have you also made your own disk images from scratch? Yes, I have. Plenty of times. Not the SE30 hack system software, but yeah, I definitely installed. I made a System 7.1.1 image from scratch for this computer. I used it with my BlueSCSI. That's a process I'd be happy to walk anybody through. It can be bootstrapping a fresh Mac OS system software, whatever version on a Mac, can be a little tricky, but there are lots of good ways to make it happen. There we go. So this is one of those, turn on your computer, go have lunch, and then you can come back and be productive, right? Yeah, I think 7.1 boots fairly quickly, especially if you have cleaned out unnecessary extensions and control panels. I mean, 8.0, 8.1 aren't even supposed to run on this machine. We do it just because we can. And I think we are in. So maybe somebody can time that another day and tell us how long it takes. Okay, it's still not responding. Here we go. About this computer. Woohoo! macOS computer, macOS 8.1, built-in memory, 128 megabytes. See if I can. I really need. So I'm working on a way to capture images directly from a black and white Mac. But let's see if I can show you. That's pretty visible, right? So there you have it. It's proof that we can get 128 megabytes of memory on this thing and run macOS 8.1. That's a thing, you know. It's probably not gonna be my default setup for this machine unless I get an accelerator. But it's pretty cool that you can do it. And with that, I suppose we have a machine that's kind of have all the parts and at a place where I wanted it to be. Of course, I have to do something. There's some work to do with the BlueSCSI still. I have to replace the micro SD card slots. I need to figure out why we're not getting power to the power and activity headers, because I still want the LED to work with this thing. And then, of course, put everything back together. So, yeah, unfortunately, I couldn't get to a fully assembled machine this time, but at least it's working. And I have 128 megabytes of memory. So that's pretty awesome. So I think I'm going to wrap it there for today. Thanks everyone for watching. And see you all next time. Have a great rest of your day, evening. Bye.